Alright, quick video on cosine and tangent following the tour de force of sine, where we examined in excruciating, painful detail, probably at risk of boring the viewer, every little detail about sine. We'll do this a little bit faster for cosine.
So cosine starts at 1.
Exactly. Cosine is the x-coordinates, so x is 1, x is 0, x is -1, x is 0. So there we've got cosine doing this deal between 0 and 2 pi. And just like sine, cosine is going to have a period of 2 pi. Okay, so there's the basic cosine graph. Now let's do the basic tangent graph.
Okay.
So now we're going to do tangent, which means I got to cross everything out. Now we're graphing tangent. And all this is wrong. And our graph is even at the wrong scale. So I'm going to graph.
Isn't it, was it pi over 2 to pi? Or was it, no?
I'll do negative pi over 2.
To pi over 2.
Right. So we need these little smidgens at pi over 4.
And we have asymptotes.
Yes, yes, yes. So you are ahead of the curve here. I like to think of tangent of theta as the slope. And we can see that when theta is negative pi over 2, we can call that a negative infinity slope. When theta is negative pi over 4, we can call that a slope of -1. I'm using m for slope. When theta is 0, we can call that a slope of 0. When theta is pi over 4, we'll call that a slope of 1. And then as we approach theta going to pi over 2, so theta goes to pi over 2, the slope becomes infinite. So it's better to say that as theta approaches negative pi over 2, the slope approaches negative infinity. So how do I draw that in a graph? We'll zoom out a little bit and draw some dotted lines here at negative pi over 2, positive pi over 2. Tangent is 0 at 0, -1 at pi over 4, +1 at positive pi over 4, and approaches infinity, negative infinity, positive infinity, as we go to negative pi over 2 and positive pi over 2 respectively. Connect the dots in the middle, and there you go. There's your basic tangent function. Notice that the period is going to be actually pi in this example. Once I cross the threshold of pi over 2, I'm back to very negative slopes. So pi over 2 to 3 pi over 2, we're going to repeat the same pattern, where I'm going to be -1 at 3 pi over 4, 0 at pi, and 1 at, what is that, 5 pi over 4?
Mm-hmm.
There you go. Okay, so that's how we would graph tangent. Amplitude doesn't have any meaning for tangent. Real quick, we'll do a couple of examples of cosine shifts, and then we'll do some tangent shifts. So how about something like y equals 2 cosine x plus pi? If you remember from our discussion of sine, we are going to shift left pi, according to this, and stretch up and down by a factor of 2, according to this right here. Okay? So, maybe I'll mark negative pi over 2 and negative pi. So cosine of 0 happens at x equals negative pi. So again, happens is in quotes. In other words, we are moving this point to the left pi and then stretching it by a factor of 2. So first thing, I'll move all the points that are 0 because those don't get stretched.
Yeah, so basically, I might be repeating what you just said, is that you start out with the shift, and then you would just graph cosine, and then multiply those points by 2.
Yes, right. So here. Make sense? And we can see what's happened is this point became, this point is there, this point is there, that point is there, this point is there, and so on. The old point that was here is now here, and so on. Compare that to the book tries to do something sneaky and say, ooh, can you graph y equals 2 cosine x, and then they put the plus outside.
Yeah, that's easy.
Right, of course. So now I would take, if I was just graphing, I'll do it in yellow, if I was just graphing 2 cosine x, it's going to be here, 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 and here. And then I don't really have space on the page, but we can imagine shifting up by pi. Pi
It's
is
a little
like,
over 3.
Right, so if I want to shift 2 becomes something like 5, so then...
But to be accurate, like if you had the professor who was ferocious,
Right.
You could just write it as 2 plus pi.
Yeah, you wouldn't do anything but that, so I would have some y coordinate up here, and I'd call it 2 plus pi, and that's where I'd put this first point, and then I'd say...
So if the professor's like, well, what's that? You'll say, well, it's 2 plus pi.
So I'm going to try to do... so it's something like this. Okay, enough. We've made a mess of the page. Alright, finally we'll play the same kind of game with tangent. Vertical stretch for tangent is a little more subtle, I guess, in the way you draw it. So the book asks for...
That'd be a good name for a movie, Vertical Stretch. Yeah.
Y equals 4 tangent x. Well, that's a little... we don't really have room to draw that. So we'll do y equals 2 tangent x. And 0 is going to stay the same.
Yes.
1 will become 2.
And negative 1 becomes...
Negative 1 becomes negative 2. And the rest is limited by your artistic ability. Meaning, it's hard to really indicate...
You just get them up by the asymptote.
Yeah. It's hard to really indicate what's happening outside of these 3 points when I'm talking about a vertical stretch. The other question the book asked for is y equals tangent x minus pi over 4. Okay, we know that's a shift of pi over 4 to the right.
Yeah.
Which means we have, maybe I shouldn't write that. I'm not going to write that in green. I'll do it in
Pink.
pink.
Is there pink?
Is there pink?
No, there's purple.
Purple. y equals tangent x minus pi over 4. So one way to anchor this, I guess, is to first shift all of the asymptotes to the right by pi over 4. And we remember an increment of pi over 4 is exactly halfway between 3 pi over 2 and 2 pi, or negative pi over 2 and 0. And then, now what? We'll have a 0 here, we'll have a 1 here, and we'll have a negative 1 at, we'll have a negative 1 here. Okay, so it's getting harder to follow the screen. Alright, there you go. There's an artistic rendering of all things tangent.